Today we're going to look at going from radicals to exponents. So yesterday we looked at going from exponents to radicals. Essentially, we're going to use the same thought process, just in reverse, okay? First thing I like to do is look what's out here on the edge and know that this is going to have or make my denominator of all of my exponents 3. Okay, if it was a 4, it would be 4, so on and so forth. Because it's 3, I know that I must have had at least 3 8s be pulled out, because I have an exponent of 1 here. So I'm going to rewrite this as the cube root 8 to the third times x squared. There was 2 groups of 3, so x to the 6. Let me go x squared to the third times 4 squared times x squared g to the 7th. I would then come in here and simplify all this stuff. So if I do 8 to the third power times 4 squared, I get the cube root of 8192. So I'm going to multiply my like terms together. X squared raised to the third power is really just x to the 6th times x squared. Remember, I just add exponents when I'm multiplying product of powers. And then g is by itself. And then we're done. All right, so to do a couple of examples, starting off with number 4, right? I want to look out here and see what's on the shelf. I don't see anything, so it's an understood 2. Take the prime factorization of my number first. 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. The bigger the number, the harder it'll be to do right off the top of your head. And then we'll c to the 6th. 6 of them. So what I can do now is make a group. And again, what's out here on the edge tells me how many I have to have. 2 2s, 2 C's, 2 more C's, and 2 more C's. And again, 2, 1, 2, 3 C's. Whatever's left over, which is a 3. 2c cubed times square root of 3. And then I'm going to change whatever's left inside the radical to a rational exponent. Remember, if you don't see anything on the shelf, it's a 2. So 2 times c cubed times times 3 to the 1/3. All right, and if this is correct, my graphs overlap. So y equals the square root 12c to the 6th. Y equals 2c to the 3rd times the square root of, whoops, I typed my answer in wrong, times 3 times 3 raised to the 1/3. And again, this is one of these functions that we're only interested in so I typed this wrong. This should be a 2. Right, but we're concerned with, so let me first go back. If you looked here, I had a fraction of 1/3. I zoomed in a little bit, and I was getting ready to talk about what I'm fixing to talk about, but first I want to talk about this. See, I was able to zoom into my graph, and I could see that I had 2 different graphs. I had a blue graph and a green graph. Well, they weren't the same, so that got me like thinking I messed up somewhere if I was confident in my work. I then paused and went over here and looked what I had written, and here is where I messed up. This is no good. It should really be 2c cubed times 3 to the 1/2 because my index is 2, not 3. Okay. Another reason why I don't like to do this stuff by hand, I'd rather just put it in Desmos. But this example is one of those where I was telling y'all about that we're only concerned with the positive x values. Okay. So I want to test x equals 1, 2, and 3. So I'm going to pull up a table. When x is equal to 1, I get 3.4. 3.46. And I get 3.4641, so that's good. When x is 2, I get 27.71. When x was 2, I get 27.712813. So those are also the same value. And then I want to try 3, and I get 93.53. So in 3, I get 93.53 as well. So because these are the same values, I know my answer is correct. The reason we don't care, well, I ain't gonna say we don't care, the reason we don't use negative x values is because when we use negative x values, it makes crazy things happen inside the radical. Last one over here. So if I want to change this to rational exponents, you can do, again, one or two things. You can just leave this stuff over here on the left alone and multiply times 2, right? 8 over 6 times y 4 over 6. And then from here, multiply like terms. So my like terms would be my 3 times 2 to the 8/6 power. Right now we get some kind of decimal. And then if I look, I get x cubed, and I have y's. Now this is what you can't do. 3 to the first power times 2 to the 8/6 and say, oh, this is 8, or excuse me, 6 to the 14 over 6, okay? The reason you can't do that is because our bases are unlike, so maybe I should have rephrased that different. You multiply like terms, and remember, when you have exponents, your like terms must have the same base, okay? So this actually winds up being 3 times 2 to the 8 over 6 power times x cubed times y to the 4 over 6. And what your answer is probably going to ask you to do is simplify these fractions. 8 over 6 is really 4 over 3. X cubed is still x cubed. Y to the 4/6 is just y raised to the 2/3.